All right, guys, 3 more factoring type problems. This first one, remember we want this to equal 0, so I need to move my 225 over by subtracting it. So we get x squared minus 225 equals 0. This obviously is a difference of squares because we have a subtraction sign in between. We have our a term, we have our c term, no b term. So remember with this, we have our 2 sets of parentheses. We can split to be x, and the square root of 225 is 15. And 1 needs a plus, 1 needs a minus, still equals 0. So obviously we get negative 15 and positive 15. We can just write that as x equals plus or minus 15. Okay, second one. This one looks tricky because it's x to the 4th power minus 10x squared plus 9. But it's very similar to a normal trinomial where it's just squared x, no x. We can treat it the same way. So our leading coefficient, this is important, it's still 1. All right, so we can just split this right away to be, instead of x and x like we do when it's x squared, we're going to go x squared, x squared. All right, and then we have to think our a term times our c term is 9. So what 2 numbers multiply to be 9 and add to be negative 10? Do a little side work down here. Well, that's going to be 9 and 1, right? 9 and 1 multiply to be 9. And it looks like I'd have to make them both negative, and that'll work. So x squared minus 9, and put a negative 1 here. And the reason we can do this is because notice it would still be x squared no matter which way I put the 9 and the 1. So this actually becomes 2 sets of difference of squares problems like we did in the first example, where again I get this first part to be, let's see, I'm kind of run out of room here. Bring this one down. This would be x plus 3, x minus 3. I'll bring this one shorter. X plus 1, x minus 1. So this one's actually going to have 4 different answers. Right here it's going to be x equals plus or minus 3. And on this one, x equals plus or minus 1. So it kind of looks like 2 answers, but again, it's 4 because this is 2, a plus or minus. This is 2 with the plus or minus. All right, last problem we have here, number 3, says 6x to the 3rd power minus 3x squared equals 45x. The first thing we have to do is get our 45 over. And so let's do that. We have 6x to the 3rd, I almost messed that up, equals, or not equals, minus 3x squared. Subtract the 45x to the other side, equals 0. Now that equals 0, we can see first off, is there any GCF? Yes. These are all divisible by 3. Okay. Again, we can do this because I do it to both sides of my equal sign. Okay, on there and there. That gives me 2x to the, man, I did it again. 2x to the 3rd power minus x squared. And then 45 is divisible by 3. That gives us 15. Should probably do it a little faster. And 0 divided by 3 is 0. Okay. Oh, 15x. Now, these all have an x in common. Need to factor out an x before I do anything. And again, another GCF. Probably could have done that in this step, I guess. But we did it to both sides, so it's fine. And when I do that, x is 2x squared minus x minus 15. All right, now this finally starts to look like a normal factoring problem. A term times our c term is negative 30. Again, do a little side work over here. 2 numbers that multiply to give me negative 30 and add to give me negative 1 would be 5 and 6. And I would have to make the 6 negative. Okay, so I'm going to split this. Let's make this 2x squared. Split my b term to be 5x, positive 5x, negative 6x. Those are the 2 numbers we found. That's where we use them. All right, still equals 0. And we can put the x on the outside still. If I group that, if I group the inside, I'm going to bring my x to the bottom here in a second. But I can take out an x, another x, and that gives me, what does that give me? 2x plus 5. And on this one, take out a negative 3, and that leaves me with 2x plus 5. That's good. These have to be the same in order for it to work by grouping. Okay, so I have a couple things going on. I have this x from out front that I brought down from earlier, And then on the outsides of these 2x plus 5s, I have x minus 3. Throw that in a set of parentheses. And the other part on the inside, we have 2x plus 5. Okay, this all equals 0. And remember, the whole point of this is to figure out where this crosses our x-axis. And in order to do that, we need to set each of these different terms, if you will, set equal to 0. And so, because that would make our equal sign true. If x was 0 and everything else was something different, 0 times whatever that is going to give us 0. So x can be 0. In this set of parentheses, if this is 0, again, times the rest of it, that would give us 0. So to make this 0, this would be a positive 3. So x equals 0, x equals positive 3. And our last one here, set 2x plus 5 equal to 0. Subtract 5, divide by 2, x equals negative 5 halves. So 3 answers on this one. Kind of some trickier type of factoring problems, but again, you need to know how to do all of these.